We're going to talk about a to the u today. Online already is your review on my math lab for your test on Tuesday. So go ahead and start that tomorrow. You can actually start it today too. I've had lots of people start it today. You want to finish that through the weekend. Come on Monday with questions, all right? If you don't finish, it's fine. But the thing is, you won't know what you don't know, okay? And then you won't be able to ask me. Yeah, you can turn it on paper if you're in class, okay? If you're online, you need to turn it in online. All right. So tonight, what's due is your A to the U homework, okay? If you're here in class, then you'll just show that to me on Monday. You don't have to wait. Yeah, it's the backside of your E to the U. I'm about to pull grades, so make sure your E to the U homework is done, which is last night, okay? And tomorrow, I don't really have a checkoff for your remote. Your checkoff is really that you were here today, basically, okay? But your A to the U homework is due tonight for those of you guys online. And I'm not gonna actually check it tonight, but make sure that you guys do upload it, because if you don't, then it'll just be counted, you know, like a 0. Okay, all right. Any questions on what we're doing for the rest of the year? Those are good. So your test, guys, is on Tuesday. If anybody's in band, they're welcome to take it. Nobody's in band in here, are they? Oh, okay. Then you're welcome to take it on Monday early or on Wednesday. It's up to you. Okay, let's go ahead and get started. We're gonna do something extra today. We're gonna add something extra to the E to the U. Here we go. What is ln of E raised to the X? Ln of E raised to X. It's X, right? Why is it X? Because if you log a tree, the cat falls out. Okay, what about E ln of X? X, okay. What about ln? Okay, guys, we're in our notes, just FYI. So if you guys pull out your notes that we've just been working on, okay, that whole packet, we're at the end of that packet. And then tomorrow, I think I might have put some notes up, but you guys can pretty much ignore that unless you just want to work some more problems, because tomorrow is just some review problems, but you might as well just do your review, okay? All right, what is ln of E raised to the 2X? 2X, okay, and I want to clarify something real quick. Okay, Joshua, can I see your face, please? Also, Farah, thank you. All right, and so right here, I want to clarify something. This ln, do you agree that it really is log E, right? It's just a shortcut to write ln. So ln of E2 to the X, that is equal to 2 to the X. That's really what we wrote here, ln, which is really log E, okay? And this E, when it's the same as this E, then the cat falls out, basically, right? So down here, if this is a log 3 to the 3, guess what happens? The cat still falls out. This cat is really resilient, okay? Over here, if I have E raised to the ln, okay, or E to the ln, okay, what's gonna happen here? The cat's gonna fall out again, okay? But remember, this ln is really log E. So this was really E log E x cubed plus 5x minus 1. So if you have E log E, that's when the cat falls out, okay? So what if I have 3 log 3? What do you think is gonna happen? That silly cat is gonna fall out again. Okay, everybody good on like notation? So today what we're gonna do is this 3 to the X, okay? So let me talk to you guys about what we're gonna do. Can you guys pull out your formula sheet, please? Guys, if you're online and you don't have a formula sheet, you need to print one out. And I moved it to resources, guys, so you would see, you could find the copy of the formula sheet a little bit more easily on the Schoology. But you guys need to find d dx of AU on your formula sheet, and please write equals A to the U times du dx times ln of A. Okay, this is another formula you're going to memorize, and your test, guys, will have no formula sheet. It'll have no formulas on it. You need to memorize all these formulas, all the formulas that we've done so far. Okay, so all the derivative formulas, the derivatives of all the sines and cosines, all of them, the derivatives of, I don't know what else, the tangents, all of those derivatives, okay, you need to have memorized, all right? Okay, so this right here, the way we're gonna do this is like, what is A to the U anyway? Well, do you remember, up to this point, we know the derivative of x cubed, okay? The derivative of x cubed is 3x squared. Do you agree with that? But I didn't talk about this much, but we did not know the derivative of 3 to the x. That's different from the derivative of x cubed, okay? This is the format x to the n. This is the format a to the u, okay? And that's what we're doing here. We're saying, hey, if our x is not in the base, if our x is in the exponent, it's a different formula, okay? And that formula is, okay, is this formula right here. Your a is your 3, so this is your 3. Your u is your x, so your u is your x. Anytime you see a, b, or c in calculus, it's a constant. Anytime you see a u in calculus, it's an x function. It's a function with x in it, okay? So what this is let's see if we can do it. First, you copy a to the u. You just copy it. So the derivative is 3 to the x. Then you multiply it by the derivative of the exponent, okay? What's the derivative of x? 1, okay? Then you multiply it by ln of a. What's a in this problem? A is your 3. So this is the answer. The derivative of 3 to the x is 3 to the x times 1 times ln of 3, okay? Yesterday we talked about e to the x, or e to the u. Do you remember yesterday we said that the derivative of e to the u is equal to, and you have this on your formula sheet somewhere, e to the u times du dx. Do you have that on your formula sheet? Well, isn't e a constant, right? Isn't a constant? And isn't e a constant? Okay. Well, this is your a, your e is your a, du dx, that's the same. So I'm missing this ln of e, or am I not? What is ln of e? It is actually a 1, and that's why when we do the derivative of e to the u, we never say this ln of e at the end, or the ln of a. You could, it wouldn't be wrong, but it's the exact same formula as the a to the u. Do you guys see that? It's just the e is special, so we don't talk about it. Kind of like your uncle on your mother's side. You just don't talk about him, okay? So it's just ln of e, and it just cancels to 1. All right, so let's do a problem, and let me point out something else too. We know how to do x cubed, okay? That's the, if x is in the base, that's going to be the power rule, okay? If x is in the exponent, this is going to be the, I guess, the a to the u rule, okay? But guys, we don't yet know how to do this. If there's x here and an x here, okay? Not yet though, but it's coming, dun, 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 but it'll come next year, okay? All right, let's look at how we would actually implement this. Okay, let's do our first problem. This is in your notes. All right, we're going to do the derivative of 5 2x, okay? So y prime is going to be, remember, it's 3 steps. First, it's a to the u. So you just copy it. Got it? Then you multiply by the derivative of your u. Got it so far? There's one more thing I need to multiply though. What is it? ln of 5, and I'm done. Do you guys see how easy this is? The only thing I want to warn you is it doesn't matter what order you put these in, okay? So if it's a multiple choice test, you might have something like this, or you might have something like this. Okay, do you see all 3 of these things are exactly the same thing? Now be careful. Right here, what a lot of students do wrong is they multiply the 2 and the 5. You're not allowed to do that because this 2x, this 5 belongs to this 2x. Do you see that? Exponents before multiplication, okay? So you cannot multiply this together. So this is really just stuck the way it is. Another thing students do wrong is they'll multiply the 5 and the 2. You can't do that. Why can you not do that? What does the 5 belong to? The ln family, okay? So even though they're next to each other, a lot of times I'll put parentheses here so that you know you can't multiply the 5. You can't take the 5 away from its family. That's just sad. You don't even know how old he is, okay? And then over here, you can't take the 5 away from his family, okay? All right, let's do another one. Okay, y prime equals, we're going to take the derivative, okay? You help me with this one. First, you do what? Copy it. Yeah, you just copy down exactly what you have. Then you multiply it by 2 more things. What's the first thing you multiply by? The derivative of the exponent. And then one more thing you need to multiply by? ln of the base, so ln of 3. Do you see how easy that is? Okay, let's do another one. Okay, this one, be careful. A couple of things students will do wrong. Some students, I'm not really sure, some students will do this. They'll go negative x times x, which is negative x squared, carry down the 6, x, negative x minus 1. They'll do the power rule here. Do you see that? You cannot actually do the power rule here. Why not? Because you have an x in the exponent. Does that make sense? So this actually is not a power rule. So please be careful with that. This one is product rule. Exactly. There's two x expressions here. Okay. With this x, you could use the power rule, but not with this 6 minus x. So let's try it. Here we go. The derivative of the first times the second plus sign plus what? The derivative of the second. Okay, now remember, this is a to the u. We can do this. First, you do what? Copy it. Then you multiply by what? The derivative of your exponent. Then there's one more thing you need to multiply by. It's something extra. What is it? The ln of 6. Bam. Okay, let's see what I've done. The derivative of the first times the second plus the derivative of the second, oops, what did I forget? Times the first. Now be careful. This is not 6x. Do you see why? Because the 6 belongs to the ln family. Okay, so you need to put parentheses here just so you don't accidentally multiply them together. If I were to simplify this, I would get rid of this 1 here. This negative 1 can actually be multiplied to this positive 1 at the front. It can be really moved to the front. So this will be negative 6 negative x. Still has the ln of x and 6. So those are all the same. But the negative 1 can be moved to the front. So you have a negative here. And then this one, all you do is drop the 1. Okay, any questions? Remember that you have a multiple choice test. So I'm going to point something out. Multiple choice tests are not necessarily easier, especially when you're doing a lot of these algebraic manipulations. Because you might have this right if it were a free response. Like if you stop there, you'd be fine. But you might not find it on your multiple choice. And you'll see a similar problem like this on your review. Hey guys, can you guys hear me? Okay, thank you. All right, so this is actually a great answer, but I want to point out to you guys, and you'll see this on your review as you do it. When you go look at my answer, it's going to take away what factors does both this term and this term have in common? Do you see? 6 to the negative x. So you can actually pull that out. And I'm not saying you have to, but I'm saying if it's a multiple choice test and you don't see this on your multiple choice, if you pull out a 6 minus x here, you'll have a 1 left over. If you pull out a 6 minus x here, you'll have an ln of 6 times x left over. Do you guys see that? And that could also be possibly an answer if it's a multiple choice. Okay, so just watch out for algebraic manipulation. Okay, let's do another problem. Okay, guys, not this one, but oops, this one. Oops. Okay, which rule is this? Quotient rule. Okay, let's do it. Okay, it's going to be the derivative of the first. So that's 3, 4t, okay, derivative of the first, times the derivative of the exponent. Oh, what am I doing? The derivative of the first. Okay, sorry. First you pull down the AU, then what's your next term? The derivative of the exponent. And then one more thing. What's that extra thing we do? ln of 3. Okay, we're done. The derivative of the first times the second, okay, minus, this is quotient rule, the derivative of the second, so that's the derivative of t. What's the derivative of t? 1, okay, times the first. And times the first means I just copy it basically. Okay, let me see if I did this right. The derivative of the first times the second minus the derivative of the second times the first, all over, what's it all over? T squared, okay? If that's all done, then I think really I'm just going to simplify this, but I want to point out something. Can I multiply this 3 and this t? No. Okay, so I'm going to put parentheses there just so I don't accidentally do it. The only thing I would do is take away this 1. You guys good with that? To simplify it, because you don't really need a 1 there. Everything else stays the same. Things might be in the wrong order, like, you know, they might switch these 4 things. Some people might move the t Yeah, yeah. Some people might move the t to the front. And then, like Becca just said, some people might factor out the 3, 4t. So actually, let me just, okay, let me just go ahead and move the t in. I'm not saying you have to. I'm just saying you can, okay? This would be over t squared, and this is y prime. And guys, this is a really great answer. This is a free response. If you got that right, then you're really in good shape. But you can also see, since your test is multiple choice, all right, these have the same factor in it. They both have 3 to the 4t. So you actually could take it out. If I took it out here, in the first term, what I'd have left is 4t ln of 3. In the second term, I took out everything, so all I have left is 1. And this could be over t squared. Okay, and again, you don't have to do it, but I want you to see that it could be a multiple choice answer. Okay, let me go ahead right now, guys. I like to do 2 things. I'd like to summarize all the formulas that you need to know for this test. And then you guys can kind of see a big picture of what we've done. Okay, yesterday we did e to the u. The derivative of e to the u was e to the u du dx, okay? Today we did a to the u, okay? A to the u is really e to the u, okay? But it's a to the u times du dx, and there's an extra ln of a here. And of course there's an extra ln of e here, but we just disregard it. Okay, we also, the days before, we did the derivative of ln of u. And do you remember what the derivative of ln of u is? U prime over u. And after we did that, I think this was Monday's lesson, we did the derivative of log AU, okay? And what was the derivative of log AU? Do you remember? U prime over u times ln of a, okay? When we did these log problems, we could also, if they were too hard, we could also pull in our log properties. Do you remember that? And the log properties were, okay, if you had log 3, it didn't even matter what it was. If you had 1 log fraction, that was equal to, do you remember? 2 log subtraction, okay? And you didn't have to use this. It was only if you felt like these were too hard to do. Now remember, this is only true if you have a log, okay? If you don't have a log, you can't do 1 log fraction equals 2 log subtraction. The other thing you need to notice is if you take the derivative of a log, there is no more log in your answer. Oops, I guess there is actually if you did this log, if this log a, okay, but not this log, okay? And then you also learned another log property, and that was 1 log multiplication equals 2 log what? Do you remember? Summation. Okay, so that was another log property, and it might help you, it might not. Only if you think it helps you, then you use this. And I think on your test, there's 1 that you have to, well, you don't have to use it. There's 1 that you can if you want to. You don't have to ever. You can always just use this u prime over u and get a stomach ache. Hey, that's up to you. Okay, and I think that's all the formulas you have on this test. Besides, you need to know all your formulas anyway. So all the derivatives that you've learned already, you need to know. So sine u, cosine u, and so on, all of these. I'm not going to write all of them, but cosine u, du dx. This one's negative sine u, du dx, okay, and so on. There's a whole bunch. There's 6 of them that you need to know, okay? So make sure you know all of those formulas, and I think you're pretty good to go, okay? All right. I want to, at this time, go ahead and look at your homework. The last question on your homework, I really just want to help you guys with it. It's not very hard, but you guys kind of freak out sometimes when you see tangent line. So I just want to remind you guys that you know how to do this. But your last problem in your homework asks you to write the tangent line of this function at 2, 1. Okay? So there's the function, there's the point. And guys, if you need to write a tangent line, what 2 things do you need? A point and a slope. So that was what you will write on your paper. This is from today's homework. So this is the A to the U homework. Point and a slope. Okay. What is our point? Do we know our point? Okay, 2, 1. Okay, guys, your point is just your X value and your Y value. You guys good with that? And notice, guys, even though they told us our both values, they didn't really need to tell us our Y value, right? Because our Y value is right here. Y is equal to 5x minus 2. We could have figured out our Y value. Look, if you know your X value is 2, right? Everywhere there's a x, you would put in 2. What is 2 minus 2? Isn't that 0? What's 5 to the 0? 1. Is our y value 1 when x is 2? Yes. So they don't actually have to tell you the y value, but they did. So thank you. Okay. But you didn't really have to be told that. All right. And then we need our slope. We need the slope of the tangent line. What did I say? We need the slope of the tangent line. When I say derivative, you say slope of a tangent line. Okay, so really, what are they asking here? The derivative. Okay, so we want the derivative of y. Okay, there's the y. Go ahead and write the derivative, guys. You guys can do it. The derivative of a to the u. We're working on your homework tonight. That's the back of your homework from last night. Okay, the derivative of y is, you copy this down. You take the derivative, you multiply by 2 more things. The derivative of x minus 2 is what? 1. What's a derivative? And then there's one extra thing. What's that extra thing? Ln of 5. Okay, there we are. That's the answer. But here's the thing. You can't have an x. You got to have all numbers. Okay, how do I change this x to a number? Plug in your x. What is your x? 2. Okay, so let's plug in 2 there. Times 1, I'll disregard that. Guys, how do I turn ln of 5 into a number? Trick question. It already is a number. Everybody good? Ln of 5 is a number. Go put it in your calculator. Hit ln 5. It's a number. Okay, it's like me asking you, how do I change 2 pi into a number? Right? It's already a number. Okay, so you don't have to worry about changing this to anything. It is ln of 5. Okay, if you go change it to a decimal, then now you have something inaccurate. Does that make sense? I mean, you're fine with ln of 5. Well, I'm fine with it. Okay, 2 minus 2 is 0. Still, we're multiplying everything together. What is 5 raised to the 0? 1. So do you see that this is really just ln of 5? Okay, so I've got my slope. I've got my point. You guys do it. Write your equation of a tangent line. Equation of a tangent line. Okay, Emily, let's see if you can write it. Y minus y is equal to the slope times x minus x. Did you get it? Okay, now I just want to point out to you guys, this is a great answer. This is the point slope form. But your test is multiple choice, so it's actually very likely that it would solve for y, okay? If it had an ln of 5, I think it would stop there, okay? But it could distribute this, okay? So you could have ln of 5 times x, okay? So that would be x times ln of 5. Okay, Paula, I know you're doing your formulas, but you should probably pay attention to this too. So ln of 5 times x, okay? And then if I distribute this, this would be minus 2 ln of 5, and then plus 1. Is everybody good with that? So this could be your answer. This could be your answer. This could be your answer. I'm going to do one more thing, and you guys are going to try to figure out how come this could also be your answer. This right here could also be your answer. Can you tell me how I got this 25? 5 squared. Where did I get 5 squared? Remember that the 2 could move to the front, right? You could also move the 2 back, okay? I don't think something like this is on your test, but if it is, because it's my math lab, I don't know, I didn't look at all the answers from my math lab, but if it is, make sure you know, remember this property where an exponent can move to the front, but also the exponent can move back also, okay? So just watch out for that. All right, let's go look at homework from last night. What questions do you guys have on your homework from last night? The last one, okay. So we're looking at number 9 on your homework from last night. And we want the second derivative of f of x. And f of x is 3 plus 2x times e to the negative 3x. You guys good? This is product rule. Now, you guys can tell me, I can do it either way. Do you want to distribute first and then do like 2 things, or do you want to just go ahead and do product rule? No matter what, we have to do like a bunch of product rules, so it doesn't matter. Okay, let's do product rule. Here we go. It's going to be the derivative of the first times the second that's a 3, plus the derivative of the second. Now, what's the derivative of e to the negative 3x? E to negative 3x times one thing, what is it? Times negative 3, or negative 3 e to the negative 3x if you want. Derivative of the first times the second plus derivative of the second times the first. All right, I'm going to simplify this. This is 2e to the negative 3x minus 3e to the negative 3x, 3 plus 2x. Okay, so this is just the first derivative. I need to find the second derivative. So when I find the second derivative, I have two choices. I can distribute first, or I mean, no matter what, I have to do two derivatives. Do you see that? Because this is a minus sign here. Do you want to do product rule here, or do you want to distribute this first and then do product rule? It doesn't really matter to me. Okay, why don't are you guys okay if I just distribute this? It doesn't matter to me either, but this is how I did it in other classes. So I'm going to, because I have to take the derivative again, I'm going to go ahead and distribute this. Now be careful. Anytime you distribute a negative, okay, it's a little bit, it takes a little bit more thinking. So what I do is I always change this to a positive negative, okay, because isn't that what negative is? Negative is positive negative, okay? It's positive times negative. And what I'm going to do now is distribute that negative 3, and that's going to be easier than actually having a 3 here and then having to distribute this negative sign, okay? So let's go ahead and rewrite this problem, and all I'm going to do is distribute this negative 3, e to the negative 3x. So negative 3 e to negative 3x times 3 is just negative 9 e to the negative 3x. Do you agree with that? Only the 3 and the negative 3 can multiply together. Then I have to distribute it again. Negative 3 times 2x times e to negative 3x is really just negative 3 times 2, which is negative 6. There's also an x. There's also an e to the negative 3x. Nothing, I can't do anything with those. They just kind of keep pulling them around. Okay, so that's f. I think this is still the first derivative. I haven't taken the derivative again. Okay. Anything I can combine here, guys? Do you guys see like terms? Do you see any like terms? Okay, go ahead and combine your like terms. So I have 2 e to the negative 3x here, negative 9 e to the negative 3x. I have negative 7 e to the negative 3x. But this third term cannot be combined because it's not a like term. Okay, and so now I'm done. This is the first derivative. Now I'm going to go to the second derivative. Okay, the second derivative is very similar, but be careful. There's another what rule over here. Do you see it? There's another product rule here. So you have to change this to plus negative. Okay, if I'm going to do a product rule and I start with a negative, I always change it to plus negative. Okay, the derivative of this right here, what's the derivative of negative 7 times e to negative 3x? This negative 7, do you see it's just a scalar, right? So I'm just going to pull it to the front. Just pull it to the front and then remultiply it. So I'm going to pull it to the front. Okay, what's the derivative of e to negative 3x? It's e to the negative 3x times what? Negative 3. Okay, so there's my first derivative. On the right side, okay, I'm going to do a plus sign because that's this plus sign here. Then it's the derivative of the first. So the derivative of negative 6x, which is negative 6. Go ahead. This side? Okay. Yeah. So the negative 7, I just pulled it out like a scalar because it's negative 7 times e to negative 3x, right? So if I said, what's the derivative of, 2, actually, I guess it's not the exact same thing. Like I said, what's the derivative of 2 cosine x, right? This 2, you could just pull out, take the derivative of this, and then multiply back. So all I do is pull out the negative 7. And then what's the derivative of e to negative 3x? Oh, well, that's e to negative 3x times negative 3. This one right here? Oh, could you do it here, you mean? Or you want to do it over here? Only on the second part. Only on the second part. Do you see that? Because there's a plus sign here. Yeah, you're good. Because there's a plus sign here. This side wasn't product rule. You could do product rule here. Do you want to do it? Oh, okay. You could. Because you could say the derivative of 7 is 0. Plus, you know what I'm saying? You could. but some terms would just wipe out. Okay, so over here it'd be the derivative first, which is -6, times the second, which is e to the negative 3x, plus the derivative of the second. So the derivative of e to the negative 3x is e to the negative 3x times what? -3. Okay, so derivative first times the second, plus derivative of the second times the first, and I think the first is just, be careful, it's -6x, because I'm pulling that -6x into the first factor there. Okay, and I'm basically done, but I need to simplify things. Now, remember, when you simplify, you can't cross these plus signs, okay, unless you have like terms, you're just adding them together. Okay, so you can't cross these plus signs. So this red part right here is just -7 times -3. So you get 21e to the -3x. This middle part here is just going to be -6 times positive. So it's really just -6e to the -3x. This last part here is -3 times -6. So that's going to be +18. And I'm going to move the x to the front. You actually don't have to. I'm just going to move it up here, e to the -3x. All right, this is my answer, but this is not my answer on my key. Do you see what two things can be combined because they have like terms? Yeah, the 21 and the -6. So what's 21 minus 6? Is it 15? So this is 15e to the -3x plus 18x e to the -3x. And that wasn't bad at all, was it? Okay. Actually, Paula, that was rhetorical. Okay. All right. So this is the second derivative. Okay. What other questions do you guys have on your homework from last night? Number 3. Okay. And this is the e to the u homework, guys, from last night. So this is y is equal to e. Do you agree that this is x to the 1/2, right? X to the 1/2. Okay, and let me just go to the side here. What's the derivative of x to the 1/2? Isn't that, this is just power rule, right? Isn't that 1/2 x to the -1/2? Good with that? Okay, so let's go ahead and do this. Y prime is going to be equal to, if this is an e to the u, first you just copy e to the u. Okay, then you multiply that by the derivative of x to the 1/2. But what's the derivative of x to the 1/2? We did it over here. It's 1/2 x to the -1/2. Okay, this is basically your answer. Okay, but you're going to want to simplify this, especially if it's a multiple choice test. Do you see that the x to the 1/2? Well, actually, I don't know if you could just leave it like this, but the 1/2, it's really just 1/2 times x to the -1/2, like that. Okay, so I don't know. I feel like if you wanted to simplify it, you could say this is e to the x to the 1/2 times x to the -1/2 over 2. I mean, because really this is divided by 1 and this is divided by 1. Okay, but things aren't really simplified when you have a negative exponent. So how do you change it to a positive exponent? Right? You can move it to the bottom. And I got to tell you, I mean, you really could stop right here. I'm moving things around because I want you guys to, well, first be able to be good at algebra, not just calculus, but algebra. Okay. And then second, you need to try to figure out on your test, because even if you have the right answer, you might not be able to find it. Okay. This is really a good answer, but guys, what's another way to write x to the 1/2? Do you guys see that? Another way to write x to the 1/2 is the square root of x. Okay. What other questions do you guys have? Number 7. You guys will look at number 7 on the e to the u worksheet. Okay. This is y equals e to the x sine x plus cosine x. All right. There's several ways you could do that. You could distribute this and then do 2 product rules, or you could just do 1 product rule here. Are you guys okay if I do 1 product rule here? I've got 2 expressions with x's. Here we go. It's going to be the derivative of the first, which is just e to the x, times the second, which is this whole thing, sine x plus cosine x. Okay, derivative of the first times the second plus, this is product rule, plus the derivative of the second. Okay, what if I had given you this on the test? What's the derivative of sine x plus cosine x? Well, there's a plus sign in the middle, right? If I gave it to you on the test, you'd be saying, oh boy. Okay, you'd say, oh, I get to take two derivatives. Okay, what's the derivative of sine x? Cosine x. What's the derivative of cosine x? Negative sine x. Do you see that? So it's just the derivative of sine x is equal to cosine x. The derivative of cosine x is equal to negative sine x, and you add them together because there's a plus sign here, and then times the first, so e to the x. All right, let me change just this right side here. This right here can just change to a negative. So this is going to be plus cosine x minus sine x e to the x. All right. At this point, this is a good answer, but it turns out a lot of things simplify. Okay, there's two things you can do here, and you can tell me which one you want to do. They both have a factor of e to the x. So you could pull out an e to the x if you want to. That's a little bit hard to see, but you could do that. The other thing you could do, which I think is easier to see, is actually distribute the e to the x, and actually you're going to get some terms wipe out. You want me to just distribute? Let's distribute. This is still y prime, so this is equal to e to the x times sine x plus e to the x times cosine x. Okay, when I distribute this way, I'll get plus e to the x cosine x minus e to the x sine x. There are two things that are exactly the same that are being subtracted. Can you find them? Yeah. If you take e to the x sine x and you subtract e to the x sine x, what do you have to get? 0, right? So that turns out to be 0. So all you have left are these two things. But these two things are exactly the same. So if you have two of the same things, what's the answer? 2 e to the x cosine x. And that's your y. Is it just one derivative? Yeah, it's just y prime. Yes. Yes, that would work too. If you distribute it first, then you have two product rules, right? Yeah, and you'll get the exact, did you get the exact same answer? Yeah, it doesn't matter how you do it. Okay, what other questions do you guys have from homework? Yes. So guys, we're looking at 6 on tonight's homework. Okay, so that's g of x is equal to 5 negative x over 2 times sine of 2x. Okay, before I get too far, I know I'm going to have to take the derivative of this negative x over 2, so I'm going to ask you guys just individually before we get too far. What's the derivative of negative x over 2? No idea? Negative 1 half. Okay, how did you do that? Do you guys remember what numerators do? Do you remember what they do? They bounce out, okay? So the easiest way to do this is to bounce out that numerator. And then what's the derivative of negative 1 half x? It's negative 1 half. Why? Because what's the derivative of 3x? It's 3. What's the derivative of 5x? It's 5. What's the derivative of 3/5 x? It's 3/5. So what's the derivative of negative 1 half x? It's negative 1 half. Okay, everybody good with that? So we've settled that. Let's go ahead and do product rule here. This is going to be g prime of x. The derivative of the first. Okay, this is an a to the u problem. There are 3 factors in the a to the u problem. First, what do? You copy it. Second, what do? You take the derivative of the exponent, which you already told me was negative 1 half, so you can't change your mind. Okay, and then there's one more something extra. What was it? Do you remember? ln of 5. Okay, that's the derivative of the first. Times the second. Well, times the second just means copy that. Sine 2x plus, this is product rule, the derivative of the second. All right, so we actually now need to take the derivative of sine u. Okay, but on your formula sheet or in your mind, because you've memorized this, the derivative of sine u, isn't that cosine u times the derivative of u? Okay, what a lot of students do is they forget this du dx. They'll just say that the derivative of 2x, my u is 2x, is cosine 2x, but that's not right. is cosine 2x times the derivative of u. What is the derivative of 2x? 2. So this is actually 2 cosine 2x. Okay, not just cosine 2x. Okay, so derivative of the first times the second plus derivative of the second, and then now times the first. And that, I think, is your answer. I don't, from the front sheet of your homework, the e to the u, and that's going to be y equals 2 over e to the x plus e to the negative x. All right, we're taking the derivative of this, is that right? Okay, so we're going to do, we can do quotient rule, or we could bring the whole thing up and do power rule. Are you okay with quotient rule? Okay, so here we go. It's going to be the derivative of the first times the second. Times the second means leave it alone. And this is really in parentheses, guys. Whenever you have fractions, everything within its numerator or denominator is in parentheses. All right, it's quotient rule, so it's going to be minus. Minus what? Minus the derivative of this bottom. Well, the derivative of this bottom is really just two different things added together. So the derivative of e to the x is e to the x times 1. Good with that. And then you add it. What's the derivative of e to the negative x? Isn't that e to the negative x times negative 1? All right, and I'm going to close that parentheses up. Don't forget to multiply back to the first. Derivative of the first times the second minus derivative of the second times the first, all over, and you take the bottom and you take the whole quantity and you square it. Okay, I'm going to go ahead and simplify things. 0 times anything is 0. You still have this negative though. So this is actually negative 1 times 2. So I'm going to move the negative 2 here. And this in the parentheses will be e to the x minus e to the negative x, all over e to the x plus e to the negative x quantity squared. Okay. You have to stop there. You might not want to stop there, but this is a negative and this is a plus. So there's no way to simplify these two. Okay. What other questions do you have? Yeah. What other questions do you guys have? Yes, Maddie. Okay. From yesterday's homework? Yes. Okay. We're looking at number 4, guys, from the e to the u homework. All right. So that is, tell me if I'm not writing it right, but is this the e to the negative t plus e to the t problem? Is that the third power? Okay. All right. What's the dominating operation here? What's the outside operation? Do you see it? Do you guys see chain rule? I don't know if you guys see it. Okay, so I'm going to do chain rule here. So there's my parentheses and there's my power. There's actually a 1 here. So here we go. It's going to be 3 times 1 is 3. Okay, now it can be chain rule because this is a number. If this had a t in it, it would not be chain rule. It would be product rule. Okay, so it's 3 times 1. Leave the inside alone. So that's e negative t plus et. Oh, et. Okay, 3. Leave the inside alone, take the power down by 1, okay, then multiply by the derivative of the inside, okay? What's the derivative of e to the negative t? Very good. Negative e to negative t. So first you copy it, then you multiply it by negative 1. Do you see that? Because the derivative of negative t is negative 1. Then it's just a plus sign. This plus sign is basically this plus sign. You're going to add them together. What's the derivative of et? Et. Someone should tell them that. Okay, so then this is basically my answer. The question is, can I combine these two? Are they the same? No, because I have this negative sign here. They're not the same, so I would just leave it like that. Okay? What other questions do you guys have? You're good? Number 1, part B, yes. Is that a tangent line problem? Okay, so we're looking at 1B on your e to the u problem. Guys, if it's a tangent line, what 2 things do you need? A point and a slope. What is your point? Did they tell you a point here? 0, 1, okay? What is my slope for this tangent line? My slope for the tangent line, what is that? That's a derivative. You guys are probably thinking, does she ever get tired of doing that? Okay, so this is y prime, right? You want the derivative. What's the derivative of e to the negative 3x? First you write it, then you multiply by the derivative of your exponent. What's that? negative 3. Okay, so there's my slope. And remember, your slope has to be a number. I know that you're right, like that is the slope, okay, but it has to be a number. So let me rewrite this actually. This is negative 3 times e to the negative 3x. This x is actually 0, right? Let me tell you the number one thing students do. They go e to the 0 is equal to 0. Guys, e to the 0 is not actually equal to 0. What is e to the 0 equal to? 1. So this is actually equal to negative 3. Okay, so what do I have here? I have x, y, and the slope. Can you guys take it from here? Y minus y, okay, is equal to the slope, where's my slope, times x minus x. Did you get it? Okay, and then you can simplify this further. Okay, what other questions do you have? Yes, Alexis. Okay. Uh-huh. Mm-hmm. Yeah, you could actually move this negative like this. Yeah, you actually can combine that. Yeah, I guess it's kind of an exception with the negative 1. I don't know how to say it, but yes, you can. Mm-hmm. Then you couldn't combine it, but you could. Yeah, you're right. You couldn't. It's kind of strange. Yeah, but you can. Good question. Yes. Okay, on tonight's homework or yesterday's? Okay, so guys, we're looking at number 5 on the e to the u problem. Okay, this is the derivative of ln of 1 plus e to the 2x. Okay, so guys, the outside function here is ln though. Do you guys see that? So if we're going to take the derivative of this, the formula that you need to use actually is the ln formula. The derivative, I'll do y prime, it's equal to u prime over u, right? U prime over u. But what is my u prime in this picture? Or what is my u, sorry? That's my u. Does that make sense? Yeah, it's not product rule. Like, it's, okay, you agree that I just need to plug into this formula. That's y prime. What's my u prime? If this is my u, what's the derivative of 1 plus e to the 2x? What's the derivative of 1? It's not product rule because they're not being multiplied together. Oh, no, that's not product rule. Yeah. It's, oh, that's a good point. If it had been this, it would have been product rule. That would have been product rule. Does that make sense? Because this is one expression. This actually is this is one expression and this is one expression. This itself is actually just one expression totally itself. Good question. Okay. So what's my u prime here? What's the derivative here? What's the derivative of 1? 0. What's the derivative of e to the 2x? 2e to the 2x divided by, that's my u prime, divided by u. The u is this entire thing. Actually, that's a good question. Like, I would have never thought that. That's really good. So this is product rule over here, but this one is not. Okay, over here. All right, so this here, the 0 goes away. So my answer would just be 2e to the 2x over 1 plus e to the 2x. All right, and I don't think there's any way you can simplify that. Okay, what other questions are you guys looking at that you're having trouble with? Yes. Tonight's homework, number 6? Okay. So this is number 6 on the a to the u homework. Okay, so we have 5 to the negative x over 2 times sine 2x. And we're taking the derivative of this, right? Okay, so this is called g. Okay, so here we go. You guys good that it's product rule? Okay, so here we go. It's going to be the derivative of the first. Okay, that's going to be copy it times the derivative of this. So let me take this over. What's the derivative of negative x over 2? Negative 1/2. Bounce that out, guys. Right? Isn't this, bounce the x out. Isn't that negative 1/2 x? Okay, what's the derivative of 5x? Isn't that 5? What's the derivative of 3x? Isn't that 3? What's the derivative of negative 3x? Isn't that negative 3? So what's the derivative of negative 1/2 x? Negative 1/2. All right, so the derivative of negative x over 2 is negative 1/2 times that ln factor. Okay, so that's the derivative of the first times the second. Okay, so we're going to multiply by sine 2x, and you just copy it. This is product rule. So I'm going to put a plus sign. Okay, let me pull this over. This is a plus sign. Plus what? Okay, what's the derivative of sine u? So back to the drawing board. Yeah, the derivative of sine u, and you should have this on your paper somewhere. If you don't have it on your formula sheet, go ahead and put it in. But the derivative of sine u is cosine u plus c. Oh, no, it's not. It's just cosine u times du dx, right? Times du dx. All right, and so what is my u here? My u is 2x. I don't want the derivative of u. I want the derivative of sine x, right? I don't want the derivative of sine u. I want the derivative of sine 2x, okay? So I'm going to change this u to 2x, and this is the derivative of 2x. What is the derivative of 2x? 2. So this answer is 2 cosine 2x. So here we go. Derivative of the first times the second plus derivative of the second, and don't forget, times the first. Okay, and this is pretty much your answer. Yeah, I don't really think, I mean, you can move this to the front, but I don't think that will help much because you can't multiply this by the 5 anyway. And I think that's pretty much it. Okay, yeah, Maddie? This one right here, because the formula for derivative of sine u is actually cosine u times the derivative of this. And the derivative of that is 2. So don't forget that. If you just had an x, you wouldn't have to worry about that because the derivative of x is just 1. Okay, but if you have 2x, you actually need to multiply by the derivative. Okay, yeah, Emily? Okay, we're looking at number 2. Why don't we do all of tonight's homework together? I was just joking. Okay, 6 minus 2x. All right, you're good with product rule here, Emily? Okay, here we go. It's going to be the derivative of the first times the second, right? And then you want to add that with the derivative of the second. That's what we learned today. The derivative of a to the u is a to the u times what? Negative 2 times one more thing, ln of 6. All right, derivative of the first times the second plus derivative of the second times the first. But be careful, again, this is not ln of 6x. This is ln of 6 quantity times x. So don't multiply those together. This is basically your answer. I would maybe multiply the negative 2 times the positive 1 here, right? There's a 1 here. So that would be negative. I would maybe move the negative 2 into the front. I'll move the x to the front too, but you didn't really have to. That's pretty much all I can do to this problem. Yeah, they took out, yeah. Okay, yeah, you can see that. I mean, maybe you don't see it, right? Both of them have the 6 to the negative 2x factor. So they could pull that out. And if they pull that out, this would turn to 1. This would turn out to 2x ln of 6. Is that what the key says? Yeah, so it's the same thing. Okay.